So hi students, so let us discuss some more interesting problems on nth differentiations by using Leibniz theorem. Okay, let us consider this problem. If y is equal to a into cos log x plus b sin log x, so then we have to show this result: x square into yn plus 2 plus 2n plus 1 of x into yn plus 1 plus n square plus 1 into yn. Yes, to prove this result, first you consider the given function y. So y is equal to y, the function y is defined like this. Yes. So now y can be written as y is equal to given function y is equal to it is a cos of log x plus b sin of log x. This is the given function y. Okay, so we need to find yn plus 1, 2. That means in this one we need the term yn plus 2 is obtained by taking nth differentiation of y2. So that means first we need to find y2 find out ಮಾಡಿದ್ಮೇಲೆ ಅದಕ್ಕೆ nth differentiation apply ಮಾಡ್ತಾ ಹೋಗೋಣ. So now differentiate this with respect to x, differentiate y with respect to x. So differentiation of y is y1 is equal to a into differentiation of the function cos is minus sin of log x. So now we differentiate cos and inside function is log x. So again differentiation of log x is 1 by x. Similarly plus b into differentiation of sin x cos of log x, and again differentiation of log x is 1 by x. In both the term we have 1 by x, so you take 1 by x common factor. y1 is equal to 1 by x into this is minus a sin of log x plus b cos of log x, b into cos of log x. So taking this is xy1 is equal to minus a sin of log x plus b into cos of log x. Again I differentiate this function with respect to x, differentiating this with respect to x into differentiation of y1 is y2 plus differentiation of x is 1 into y1 as it is, which is equal to minus a differentiation of sin theta is cos theta, differentiation of sin of log x is cos of log x, again differentiation of log x is 1 by x. Similarly plus b into differentiation of cos is minus sin log x, close this bracket, again differentiation of log x is 1 by x. Now you take 1 by x common factor and we have xy2 plus y1, x into y2 plus y1 is equal to, so in both the term we can take minus as a common factor, minus of a into cos of log x plus b into sin of log x, this whole divided by x. Okay, so now take x cross multiplication, then it is x square y2 plus xy1 is equal to minus, you see a cos of log x plus b sin of log x can be written as y, because the given function y is that same, a cos of log x plus b sin of log x same ಇದೆ ಇದೆ. So now y ಬೇಕಾದ್ರೆ ಬರೆಯಬಹುದು, you can write it is y. So now it becomes minus y. In right hand side we have minus y, take this minus y to left hand side, it is x square into y2 plus xy1 plus y is equal to 0. After obtaining this y2 terms, okay, so after obtaining the second derivative of this given function, now we differentiate this n times, differentiating each term n times, differentiating each term n times, and we have used the Leibniz theorem. By using Leibniz theorem, to find its nth derivative, must use Leibniz theorem because product of two function is there. So by using Leibniz theorem, we get, so yes, nth derivative of x square y2. So I think you are familiar with the using the Leibniz theorem. So it is very easy. First you take x square, a polynomial, and for this y2 you add 1 n, so then it becomes yn plus 2. In next step you take plus, next step it is n because nc1 value is n. Okay, next you differentiate this polynomial x square, it is 2x, reduce a number from yn plus 2, so then it is yn plus 1. One number kadme ಮಾಡಿ yn plus 2 ನಲ್ಲಿ yn plus 1 ಬರುತ್ತೆ. So plus next step it is n into n minus 1 by 2 because it is nc2 value is n into n minus 1 by 2 ಬರುತ್ತೆ, and differentiate this 2x, it is 2, and reduce a number from yn plus 1, ಅದರಲ್ಲಿ ಒಂದು ಕಡಿಮೆ ಮಾಡಿದ್ರೆ yn ಆಗುತ್ತೆ. Similarly, so after getting constant, ಇಲ್ಲಿ constant ಬಂತಂದ್ರೆ, so stop the process of applying the Leibniz theorem, ಅಲ್ಲಿ ಮುಗಿದೋಯ್ತು, that is the last term. Again you take nth derivative of x y1, use the same procedure, x ತಗೊಳ್ಳಿ, y1 ಗೆ n ಹಾಕಿ, so then it is yn plus 1. Next step plus n into differentiate x, differentiation of x is 1, and reduce the number, so then it becomes yn. So if it is a constant, you stop the process. Plus the nth derivative of y is yn. Nth derivative of y is yn, which is equal to 0. So next step you can simplify this, it is x square into yn plus 2 plus, take all yn plus 1 common factor, so it is 2nx plus, here it is x into 2nx plus x into yn plus 1 plus, here you can cancel this 2, so now it is n into n minus 1, n into n minus 1, or you can write it is n square minus n square minus n, plus here we have n, when you take yn common factor remaining is n, plus if you take yn common factor in last term remaining is 1 here, this into yn is equal to 0. Okay, now simplifying this, x square into yn plus 2 plus, you take x common factor, it is 2n plus 1 into x into yn plus 1 plus, cancel this plus n and minus n, remaining here is n square plus 1 into yn is equal to 0. Okay, so now it is same as the given one. Okay, x square into n plus 2 plus 2n plus 1 x into n plus 1 and n square plus 1 into yn is equal to 0. That is the desired result. Okay, so similarly, usually these problems are asking like this, if the function is so and so, then you have to show this result. So in that format only they are asking the questions. So take one more problem of the same type. If y is equal to e to the power m sin inverse of x, so then we have to show this result. First you write the given function. So given function is y is equal to e to the power of m sin inverse of x. So let y is equal to e to the power m sin inverse of x. That is a given function. As you differentiate this with respect to x, differentiate with respect to x, differentiation of y is y1 is equal to differentiation of e to the power of x is e to the power of x. Differentiation of e to the power of anything, that anything. So you take it is a differentiation is e to the power of m sin inverse of x. Again we have to differentiate this power, that is m sin inverse of x. So now you take m, differentiation of sin inverse of x is 1 by root of 1 minus x square. So now take cross multiplication, root of 1 minus x square into y1 is equal to m into e to the power of m sin inverse of x. You can write it is 1 y next step, or you can differentiate directly, no problem. Differentiate this with respect to x. To differentiate, okay, use the product rule to differentiate the LHS. Root of 1 minus x square, you keep that as it is, root of 1 minus x square, root of 1 minus x square into differentiation of y1 is y2 plus, again a differentiation of root of 1 minus x square is 1 by 2 root of 1 minus x square. Again differentiation of 1 minus x square is, differentiation of 1 is 0 minus differentiation of x square is 2x into y1, that term as it is, which is equal to, here m is a constant, keep m as it is. Differentiation of e to the power of sin inverse of x is e to the power of m sin inverse of x. Again differentiation of m sin inverse of x is m into 1 by root of 1 minus x square. So now here this 2 and 2 cancels. Now you take root of 1 minus x square LCM. So then it becomes root of 1 minus x square whole square into y2, and now it is minus x y1 second term. This whole divided by root of 1 minus x square, which is equal to, now this is m into m is m square into, you see, e to the power m sin inverse of x. E to the power m sin inverse of x can be written as y. So you write directly, that is y divided by root of 1 minus x square. Both the denominators are same, so you can cancel the denominators. So eradu same ide, eradunu cancel ಮಾಡಬಹುದು, cancel this. So what is remaining? And also here root and square cancels, root cancel with the square. Okay, so now you write the remaining terms. It is 1 minus x square into y2, 1 minus x square into y2 minus x y1 minus m square y is equal to 0. So usually this term is very similar to the previous problems. Okay, so now you differentiate this n times, differentiating n times by using Leibniz theorem, differentiating this n times, differentiating each term n times using Leibniz theorem, So we have, so 1 minus x square into yn plus 2. So very simple method. You take 1 into 1 minus x square into yn plus 2 plus next step ಅಲ್ಲಿ ಏನು ಮಾಡಬೇಕಂದ್ರೆ, so nc1 ಬರುತ್ತೆ ಅಂದ್ರೆ n ಬರುತ್ತೆ. So you differentiate 1 minus x square, so its differentiation is minus 2x, its differentiation is minus 2x. So and reduce a number from yn plus 2, yn plus 2 ಇದೆಯಲ್ಲ ಅದರಲ್ಲಿ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಿದ್ರೆ yn plus 1 ಆಗುತ್ತೆ. In next step plus n into n minus 1 by 2, this is because nc2 means it is n into n minus 1 by 2. Differentiation of minus 2x is minus 2. So reduce a number from yn plus 1, ಅದರಲ್ಲಿ ಒಂದು ಕಡಿಮೆ ಮಾಡಿದ್ರೆ yn ಆಯ್ತು. Similarly minus ಮತ್ತೆ ಅದೇ ಥರ ತಗೊಂಡ್ರೆ minus x y1 ತಗೊಂಡ್ರೆ minus of x into yn plus 1. So next step ಅಲ್ಲಿ n ಬರುತ್ತೆ, n into differentiation of x ಅಂದರೆ 1. So and ಇದರಲ್ಲಿ one number ಕಡಿಮೆ ಮಾಡಿದ್ರೆ it is yn. So this is the nth differentiation of minus xy1. Last term is minus m squared. M square is a constant. Differentiation of y with respect nth differentiation of y is yn. This is equal to 0. So now it is, so you simplifying this, so you can cancel some of the terms like 2 and 2 cancels, 2 cancels, and you can take yn plus 1 common factor, and you write the terms in increasing order. So that is 1 minus x square into yn plus 2 first, and here you take yn plus 1 common factor. Illide andre illi matte idu eradu terms ide, so right, take minus 2nx, and if you take minus outside, so it is plus x, 2nx plus x into yn plus 1. So and again plus of, so if you take yn as a common factor, minus is remaining here, minus n into n is minus n square, minus of minus plus n. If you multiply this with minus, it is minus n into yn, minus n into yn, and in last term minus m square into yn. This is equal to 0. Here you can cancel this n and n, plus n cancelled with minus n. So now simplifying this last term, so it is 1 minus x square into 1 minus x square into yn plus 2, minus here you can take x is a common factor, 2n plus 1 into x into yn plus 1, and take minus common factor, n square plus m square into yn is equal to 0. So this is the nth derivative of the function e to the power of m sin inverse of x, right? So what is the result they are given? Minus of 2n plus minus of 2n plus 1 into x y plus 1 minus of n square plus square. So that same steps you obtained here. So take one more problem of the same type. If x is equal to sin t, y is equal to cos pt, show that 1 minus x square into n plus 2 minus 2n plus 1 x into n plus 1 minus of n square minus p square into yn is equal to 0. So of course it is very similar to that last problem. Okay, take the values of x and y here first. So take x is equal to sin t, take this is equation 1, y is equal to cos pt, y is equal to cos pt. You take that equation is 2. Now you take from result 1 we have, yes, here you can write t is equal to sin inverse of x, isn't it? So sin t is x, then what is t? T is equal to sin inverse of x. Substituting this or using this into we get that, what is y now? Y is equal to cos p into t. T is what? It is sin inverse of x. So that is y is equal to cos of p sin inverse of x. Y is equal to cos of p sin inverse of x. You take this equation is 3. Now you differentiate this with respect to x. Differentiation of y is y1 is equal to differentiation of cos theta is minus sin theta. So it is minus sin of p sin inverse of x. Again differentiation of p sin inverse of x is, p is a constant, keep it as it is. Differentiation of sin inverse of x is 1 by root of 1 minus x square. So taking cross multiplication, root of 1 minus x square into y1 is equal to minus p into sine of p sine inverse of x. Again, differentiate this function with respect to x. So differentiating this with respect to x, we have root of 1 minus x square into differentiation of y1 is y2 plus differentiation of root is 1 by 2 root of 1 minus x square. Again, differentiation of 1 minus x square is minus 2x into y1, which is equal to minus p into differentiation of sine is cos of p sine inverse of x. Again, differentiation of p sine inverse of x is p into 1 by root of 1 minus x square. Here you can cancel this 2 and 2 and take root of 1 minus x square is the LCM. So then it is root of 1 minus x square whole square into y2 minus x y1. This whole divided by root of 1 minus x square is equal to minus p into p is minus p square into, you see, cos of p sine inverse of x. Cos of p sine inverse of x is equal to, so that is y. Cos of p sine inverse of x is y from equation 3. So use that y value here. Cos of p sine inverse of x is y. This divided by root of 1 minus x square. This is from equation 3. So now both the denominators are same. So you can cancel that denominators. Root of 1 minus x square cancelled with root of 1 minus x square. And here also this root and square cancels. Root and square cancels. Now write the simplified form. It is 1 minus x square into 1 minus x square into y2 minus x y1 plus p square y is equal to 0. So now you differentiate each term n times with respect to x. Differentiating each term n times and by using Leibniz theorem. Leibniz theorem. So then we have 1 minus x square to differentiation of y2. Okay, use a Leibniz theorem to differentiate that. 1 minus x square into, first step is nc0 into uvn. Okay, so that is nc0 is 1 into 1 minus x square into yn plus 2. So plus next step ಅಲ್ಲಿ nc1 ಬರುತ್ತೆ. nc1 ಅಂದ್ರೆ n. 1 minus x square ನ differentiation ಮಾಡಿ, that is minus 2x. ಇದರಲ್ಲಿ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಿ, that is yn plus 1 plus next step ಅಲ್ಲಿ nc2 ಅಂದ್ರೆ n into n minus 1 by 2. differentiation of minus 2x ಅಂದ್ರೆ minus 2 ಬರುತ್ತೆ. ಇದರಲ್ಲಿ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಿ, so then it is yn. So when you get constant, you stop the process so that nth differentiation of that function is over ಅಂತ ಅಲ್ಲಿಗೆ. So next minus of nth differentiation of xy1 is x into yn plus 1 plus next step ಅಲ್ಲಿ n ಬರುತ್ತೆ. differentiation of x ಅಂದ್ರೆ 1, ಇದರಲ್ಲಿ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಿದ್ರೆ yn ಆಗುತ್ತೆ. plus or you close this plus p square into differentiation of y n times, it gives yn is equal to 0. So now we have this 2 and 2 cancels. 2 cancels. So 1 minus x square into yn plus 2. So here you take yn plus 1 is a common factor. yn plus 1 common factor ತಗೊಂಡ್ರೆ, So now remaining here is plus of minus 2nx minus x into yn plus 1. ನೋಡಿ ಇಲ್ಲಿ ಮತ್ತೆ ಇದರಲ್ಲಿ yn plus 1 ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ತಗೊಂಡು ಇಷ್ಟು ಟರ್ಮ್ಸ್ ಉಳಿಯುತ್ತೆ. And plus you take yn common factor, remaining here is n square. So actually it is minus is there, minus n square plus n. And if you take my yn common factor, plus into minus becomes minus, so it is minus n, and that last is plus p square into yn is equal to 0, plus n cancelled with minus n. So now you write the last step, 1 minus x square into yn plus 2. In both these terms you take minus common factor, minus ಹೊರಗಡೆ ತಗೊಳ್ಳಿ, then it is 2n plus 1 into x, you take x also common factor, into yn plus 1. So and you write it is plus p square minus n square into yn is equal to 0, because n square has negative sign. So my p square minus n square of y is equal to 0. So that is the result they are asking. Actually okay, they are writing in this form, minus of n square minus p square into yn is equal to 0. So both are same. If you take minus common factor, then it becomes minus of n square p square. Okay, no problem. Okay, write that one more time. 1 minus x square into yn plus 2 minus of this is 2n plus 1 x into yn plus 1. Take minus common factor, it is p square. So if we take minus is the common factor, so then it is, if take minus is the common factor, so now it is, if you take minus outside, so then it becomes n square minus p square. N square minus p square into yn is equal to 0. Otherwise you stop here itself. There is it is not the mistake. Both are correct answers. P square minus n square is nothing but minus of n square minus p square of yn is equal to 0. Okay. So some more problems are there in this nth differentiation. So I would like to continue that part in next classes. So thank you for your patience listening.